it, or at least you attended my class, then you realize that what I talked to you last time, that I just made this picture to make you understand that, or if you have forgotten, that we actually make 3 layers from 2 layers. We call gastrulation. That happens on the 3rd week. Today's discussion is from these 3 layers, each one, what does it make actually? How the baby will look like over the time. And the progress is from 3rd week to 8 weeks. So in other words, what we call as the derivatives of each layer, germ layer, we call ectoderm, mesoderm and endoderm. That's the topic today. So one more time, I'm trying to emphasize that at the 2nd week you have the 2 layers called epiblast, hypoblast. In last lecture I tried to indicate to you the importance of the primitive streak, the primitive peat, and how the gene is responsible for making those cells going down through the peak to form the 3 layers. The hypoblast is pushed away, but the 3 layers you see, the 3 different colors I put it over there, they are the ectoderm, mesoderm and endoderm. I give you a little orientation one more time, that if you look at this picture, that picture over there, and what is in my hand is basically the same thing. You are looking at the coronal section, anterior posterior, but each layer is like this. Each layer has a prolonged over there at the back side. So you are looking at the front only. Is that okay? So each layer is there. So I'll be taking 1 layer at a time to make you understand that what is exactly happening with each layer. And it's very important for you to understand. If you understand today's lecture, basically 50% of your embryology is clear. Trust me. 50% of your embryology, the concept is clear. You have to understand. I will repeat 10 times. You don't have to raise your hand at the outset, because I'll be repeating it 10 times to make sure that everything is clear to you. So one more time, I'm trying to emphasize today that each layer, I'll take 1 layer at a time, what does it make and how does it look like over the time. We are dealing with the 3rd week, now I'm progressing further from 3rd week to 4th week and 5th week, like that, what is happening. So I picked up the first layer, which is the ectoderm. Is that okay? Now if you look at the ectoderm, and if you look at the ectoderm over here, just below that, remember there is a line over here called notochord. You remember that line? Because that was forming the axis. Remember that there was over there, there's a line, that's called the notochord. I just tried to put it over here. Maybe I put a different color over here, so it is easy for you to understand that this is notochord, which is making the axis over there. It's a part of the mesoderm, but it is just below the ectoderm, okay, right in the middle. Now, over the time, what is happening is that ectoderm will form like this way. So, in other words, you see a tube coming up. Can you see a tube?
Yes.
Yes or no?
Yes. Yes.
Say yes. No. That's the tube I'm talking about. And the tube is possible because it is folding, right? And this tube is called neurulation or neural tube. So ectoderm, just to recapitulate one more time, last time or many weeks back I indicated to you that ectoderm is primarily responsible for the formation of the brain and the spinal cord and the skin. Remember that? So I'm going to show you how does it do that. So in the first the process is the formation of the neural tube, and that you can do it or you can think about it because it is just folding. Now why it is folding? Because something is coming out from here, from the notochord, and there is a gene called sonic hedgehog gene. Now you may say, what is this all about? Because I already put it in my PowerPoint that there are many genes over there. I said I will pick up one gene at a time in my class. Last time I kept the WNT gene, remember? Today I am taking sonic hedgehog gene, SHH, sonic hedgehog gene. Now that may be a little problem for you to understand what is sonic hedgehog gene, but it's very important. Somebody got a Nobel Prize in 1995 by bringing that gene in perspective. And what does it do? It actually, ventralization, we call it the ventral part of the tube is formed because it attracts down. So in my next diagram, I'm just trying to put this thing. You can see that this is the cell. Now it's going down. Not very difficult for you to understand what is. And here is the red color. I should use the red color over there. That is the notochord. Is that picture clear to you?
Yes.
What happened to you guys today? Nothing. You're not talking, nothing. Say yes.
Yes.
Yeah. Now, obviously, I'll be drawing that in the blue color because I started with the blue color over here. So let's do the blue color over here. Yes. Now my next diagram, look at this. The same thing I'm trying to do. And over here. Is that okay? Say yes.
Yes.
It's not a rocket science. What I'm just saying that, now you will see my next diagram, and I want you to say yes. No, not yet, not yet. No, not yet. Can you see the tube is separated now?
Yes.
Yes. Yes. So the tube, so here is the tube. Now it's clear?
Yes.
Remember other layers are there too. I just took the only one layer. We are dealing with the only one layer. And I have to make this layer spinal cord and the brain. This is my job. My job is to make this neural tube as a brain and the spinal cord. So look at my drawing, okay? Step by step. So the tube is clear to you.
Yes.
And what you see on the top is basically it forms the skin. The skin, the not like a dharma we call it. Dharma means it is the skin, or dermatome. Dermatome is one part of this, but it is a total, the whole dharma is formed, or the skin is formed based on the ectodermal derivative. Is that okay?
Yes.
You have a question? No.
What did you say the sonic hedgehog cheese was?
If you tell me now, what does it do?
What causes the sonic hedgehog?
Ventralize the ventral part. Ventral part, it does it like this. I'm coming. Let me finish my little drawing, then, Now, when you look at this drawing, make no mistake that you are looking at only this part. Is that okay? But the tube is, the whole tube is over there. So if I draw lateral view, then it's clear to you that what it is doing. So the same tube I'm drawing now. You understand this tube?
Yes.
The same thing, but it's a lateral view. Now, I'm doing the next one. The tube is increasing in size. It's the same tube. Okay? It is the same tube which is increasing in size. It's folding. This is the lateral view. Tube. You are looking at this one over here like this. You see only the round.
Yeah.
But if I do the whole tube, and the tube is increasing over here. Now, over the time, this part is called the wall. Wall of the tube is increased, and the cavity is decreasing. Can you see it?
Yes.
The cavity is decreasing, but this is increasing. The wall is increasing. Okay? Now look at my drawing. That's the reason drawing sometimes is important. Not sometimes, all the time important. All the time. Now what I'm going to do, now it is increasing. But remember, these are from the wall. It is thick, but the cavity is over here. The cavity is over here. But from the wall, it is increasing in shape, and then makes sense to you? Brain and the spinal cord? Yes or no?
Yes.
Okay, good. So now you understand that what it is happening over here. So where is the ear? Ear is over here. So I'm coming, out. No need of hand, I know your problem. I promise you 10 times. But this is not a difficult one. So first of all, through the hedgehog gene, it is pulling it down. So now the tube is forming, which is called the neurulation. Neurulation means the tube, neural tube. That neural tube will form the brain, the spinal cord, and I'm just showing you how, because from the wall, some growth is there, and then it forms the brain and the spinal cord. Okay? So these are the scenario, the changes that you must follow. While it is happening like this, there are, the third important part is also, there is something, some cells are coming out from here. These cells, underline, if you are writing something 10 times, these cells are called neural crest cell. Neural crest, very important. These are the cells. So now I'm talking about that what are the derivatives of the ectoderm. Number one, brain and the spinal cord. Number two is the skin, or the derma we call. Third one is the neural crest cells. What are these cells? These cells actually migrate. Migrate means they crawl and go to a system to be functional. The system doesn't get functional unless many times the neural crest cells go into that. I give you an example. You have the intestine, but the intestine is not functional unless the neural crest cells go over there and forms the ganglia. Then the peristaltic movement starts. Without the ganglia, there is nothing. I give you another example which you know already, that we have the nervous system, the axon. It carries the conduction. It doesn't happen without the Schwann cell. You know that? And the Schwann cell comes from the neural crest cell. So without the Schwann cell, the whole nervous system, peripheral nervous system, is not active at all. You got my point?
Yes.
So many of the systems, they need the neural crest cells to get into there, or what we call migration of the cells will be inside a system to be more functional. Are you okay with me? So a child is born, the intestine is there, but it is not functional. We call congenital megacolon. Mega means big. So why it is big? The child is hungry, drinking milk, nothing is coming out. Why? There is no ganglia. There is no ganglia that there should be a peristaltic movement. And this ganglia coming from where? Neural crest cells. So congenital megacolon is a problem for the neural crest cells, which do not get migration, or do not, migrate to a system. Somebody who has a peripheral neuropathy, you can explain more that a congenital I'm talking about, the neural crest cells do not produce the Schwann cell. Now you may think about what is a Schwann cell. Now then I have a problem. I cannot explain you right now. I'm expecting that Schwann cell, that word was in your foundation block. How many students do not know what is a Schwann cell? At the back. How many students, maybe all of you know what you don't know. You heard the name? That's very good. I'm excited. Okay. So Schwann cells, remember it comes from the neural crest cell. So I'll have a PowerPoint telling you what are the cells coming out from the neural crest cell. Is that clear to you? Yes. So you don't have to know more than this, less than that. You just have to know that there are three things are coming out from the brain, spinal cord, skin, and the neural crest cells, which are actually migratory cells going into a system to be more functional. I have to do more, so I'll entertain your questions a little later, so hang on for the time being. Now, my job is to go into the second one, which is this one, mesoderm. Okay, I'm trying to do now this second layer. Don't talk please, because the second one is, you have to pay some attention. It's called the mesoderm. This mesoderm is one layer, okay? But it is divided into three parts on either side. In the middle, you know that in the middle you have the notochord. So it is divided into two parts, but each part is responsible to produce three different subsections of the mesoderm. So let me draw that. What I'm trying to say over here, maybe this is a better area. So I'm trying to draw the mesoderm, the second layer I'm trying to do. And in the middle you have the same notochord is over here. Now the one which is close, remember you are looking at this way, but if I show you it looks like this, three parts. But when you see like this, it is like this, one. So this one, the one which is just beside the notochord is forming the axis, it is called paraxial mesoderm. Paraxis means just beside the axis. Paraxial mesoderm. Paraxial mesoderm. Paraxial mesoderm, and it is responsible for the formation of bone, vertebrae, and some muscles. Muscles, vertebrae, and some bones. Okay, that is called paraxial mesoderm. Then you have the intermediate mesoderm. So I'll just draw it in a different way now. So this part is called the paraxial mesoderm. So I use now the second one, which is over here. This one called intermediate mesoderm, because it is present intermediate area. Intermediate mesoderm. This mesoderm is important for genitourinary system, the kidney. Okay, the kidney. Why it is genitourinary? Genital system means ovary and the testes. Ovary and the testes also come from the intermediate mesoderm. And the last part, you have the lateral mesoderm, which has two parts. One is called the somatic mesoderm on the top, and this is called the flankic mesoderm. So I'll repeat it. Don't raise your hand, because I'll be repeating it 10 times, and make sure that you understand it. It's very interesting. But just hang on a little bit. First of all, you know the terminology. So this is called the somatic part, somatic mesoderm. And this is flankic or visceral. This is flankic mesoderm. Okay? Now, at the same time, it is your responsibility to understand where it is exactly in our body. If you think about it, if I behave like an embryo, I look like this. Ectoderm on the top, endoderm is the intestine, and whatever you think about in between is the mesoderm. That mesoderm on two parts are identical, because we need two kidneys, we need two testes, we need two ovaries. Make sense?
Yes.
So therefore, it is divided into three parts. One is called vertebrae, is coming is the paraxial mesoderm. Actually the vertebra has two parts, then they join. They join like this. But it has a two part, or originally it has a two part. Paraxial mesoderm, then it joined together to form one vertebral column. Then you have the intermediate mesoderm, genitourinary system, means kidney, ovary, and the testes, they come from there. And the third part, which is the lateral mesoderm, has two parts. One is called the somatic mesoderm, another one is the magnetic mesoderm. They are very important. So now you understand where it is exactly. Okay. Now if I do like this, now do not talk please, this is very important, but I'm going to show you that very important. Now you are thinking about this way now. The three layers are formed.